In this video, I will be demonstrating the bidirectional data exchange workflow between IESVE Software and Gaia Geothermal's ground loop design software. The purpose of the connectivity is to optimize both the performance of the building system design in IESVE and the geothermal wellfield system design in GLD. There are 6 steps in the data exchange workflow. Step 1 is to export the heating and cooling loads from IESVE software. In this example model in IESVE software, much of the necessary data is already set up to go. That includes site and weather data, construction assemblies and infiltration rates, internal heat gains and minimum ventilation rates, and HVAC systems. So on the western facing side of this building, where there's 5 floors, that part of the building is being served by VAV systems and also air-to-water heat pumps. Whereas on the easterly facing side of the building, which is going to have 2 new floors, that again will be served by VAV systems, but this time on the plant side is going to be served by either water-to-water heat pumps, and here we are evaluating ground source heat pumps. Now, it's important to understand that at this stage before generating simulation loads, because as we launch the simulation to generate loads, you may need to ask for additional information. If the load calculation was for the entire building, there's not much else to do. But if we need it for a part of the building, you may need to request that additional data. So for that, we go to output options and we'll ask for ApacheHVAC system results and even component results if you wanted to evaluate ground source for just one piece of equipment only. It's also required to perform the simulation for the entire year, so 1st of January through to December 31st. Simulation time step of 10 minutes or lower is recommended, and required will be the reporting interval of 60 minutes. So with that, we can perform a simulation. So I am using the parallel simulation mode available in Apache. That basically gives me faster results because it's splitting up the simulation on a per month basis. Once the simulation is complete, I'll be able to go to the Vista Pro application and export the hourly loads results. All right, so let's take a look at the results. So we're here now in Vista Pro, and there's a couple of ways to get the data. I like to start off with a visual representation. So you will see a lot of variables here at the bottom, and initially you might want to look at loads, but as mentioned previously, I'm more interested in the part of the building that's only going to be used for ground loop design evaluation. So with that, I'm going to go to the network loop, and I'm specifically interested on the plant side. And let's start off on the chill water side. So here you can see the part of the building that's being served by air-to-water heat pumps, i.e. the western part of the building. I'm not interested in that. I'm more interested in the eastern part of the building. So here I'm just going to select the chill water loop, and here you'll see variables available to you associated to the chill water loop. And I'm most interested in the chill water loop total load. So I like to start off with a graphical representation just to make sure that the cooling load is making sense to me, and I'll click on the graph and I'll change its color so that I'll know it's for cooling, and most importantly then I'll lock it to the chart. Now I'm also interested in the hot water loop. So if I expand the hot water loop here, you can again see that I've got some for western, which is air-to-water loops. I'm more interested in the water-to-water loops. So again, if I select, in this case, the primary heating hot water loop, variables will update accordingly. And again, you need to be aware of what you're selecting. So is it the total load? Is it the space heating load? And maybe these ground source heat pumps are also going to account for the domestic hot water or service hot water load. This is why the modeler needs to take ownership of what loads are being exported. So for me, I'm going to select the hot water total load, and I'll just make sure that goes to red so I can see it on this chart and make sure it's making sense to me. And the shaped profiles of those make a lot of sense. One is for heating, one is for cooling, and now we're ready to do the export. So what we actually need is the numerical data of the 8760. So here we go to the table view, and this will give us 8760 rows of chill water total load and hot water loop total load. But again, it might be different for you. It might be just a summation of all of your room cooling and heating loads. So with that, we'll do a copy, open up a spreadsheet, and paste. So the rule is simple here. We have a little bit of formatting to do. It's delete 2 and add 1. So we're going to delete the first 2 rows, or sorry, first 2 columns, beg your pardon. And then we need to add a row. So you select row 4 and then insert. The start of the data is supposed to begin on row number 5. And that's all you need to do. Once you save that as a .csv file, you're ready to do the import into GLD. Step 2 is to import those same heating and cooling loads into Gaia-GLD software. So once GLD is open, go to the loads menu and average block loads. Create a new file and then import the loads. Make sure to select the CSV file and open. So I can see the loads have appeared, and just to confirm, you can go to the monthly loads dialog and see the loads distribution over the course of the year. Step 3 is to set up the geothermal system design in GLD software. First, you can come and select a pump. There are a number of manufacturer types available. I'm going to select a Climate Master, Tranquility brand, and try to choose a heat pump type and capacity that reflects the predicted average characteristics of the installed equipment. Next, you have a choice of 3 different system configurations. You can have a vertical bore field, horizontal heat exchanger, or a surface water system type. I'm going to choose vertical bore field for this particular project. Then we need to link the loads to the system configuration, like so. And from here you can set up your fluid type, soil, bore field configuration, pattern, number of boreholes. You can even get a nice system map here. Add additional extra energy consumption values for a circulation pump or optional cooling tower, and or add general information associated to the project. Most important thing at this stage to perform the load calculation is to select hourly and then calculate. You may get a reminder that it's computer intensive, but normally it shouldn't take more than a minute to generate results. Step 4 is to export the exiting water temperature from the ground heat exchanger. So once the simulation is complete, we can move over to the results tab and view our hourly results. So here's an 8760 graph of the exiting water temperature from the ground heat exchanger. And from here, all we need to do is access the raw data. That'll open Windows Explorer. It'll be the latest data file. And you see a number of rows and columns associated to the exported data. So what I'm going to do is select everything from an 8760 basis, back to a spreadsheet, hit paste, and you'll have a number of variables. So the third last one is the one we're looking for, the exiting water temperature. Here I'll show some definitions for all of the other variables. Step 5 is to import the ground heat exchange water temperature into IESVE software. So for this we can utilize one of the scripts that come preloaded into IESVE software. That will be available in the navigators option. So we do a drop down menu and go to the bottom of the list. You should find something called VE Python scripts. Now, if the scripts are not there for you by default, all you need to do is go to the Tools menu, VE Scripts, and you'll see a long library of scripts available. The two that I've already imported are here, FFD create and FFD_CSV. For any script for that matter, all you need to do is right mouse click and promote to the navigator, and then they'll appear over here. So the first action here is to run script FFD. This is going to want to create a free-form data file that we can paste the 8760 data from Gaia-GLD. So importantly, we'll leave this at the 60-minute time step. I'm using absolute data opposed to modulating. Modulating is between 0 and 1. Absolute are obviously absolute conditions. And I've exported an IP unit, so that's the CSV I want to set up. And then you can call this file anything you want. I'll just call it from GLD underscore FFD and say OK. And that will create a CSV file for us. So to look at the CSV file, I'll go to Tools, Open Project Folder, and you'll have this new folder available in your project directory, FFD underscore data. And this is the file I've just created. So I'm going to open this up next to this spreadsheet that I've already got exporting data from GLD. Get these side by side. So column E is where I basically want to paste the data from GLD. So I've already got the column selected. So hit copy, come over here, hit paste, save, and that's it. So before I leave, I just want to make a mental note that, you know, it's 8760 data that I've pasted. Minimum values at 47 degrees, say rounding down from a conservative perspective would be 47 Fahrenheit or approximately 8 degrees Celsius. And then on the upper side, the maximum condition is about 69 degrees Fahrenheit or approximately 21 degrees Celsius. So once you save that, I'll go back to IESVE. That's the first action complete. So the next one is to create the free-form data file. So I'll select it, say open, and then it'll tell you the free-form profile has been added to Apache Profiles. Apache Profiles is available here. Let's open that. Set up with various categories. I can go straight to free-form profiles, and you'll see one called from GLD underscore FFD input data. Now this is really just to come in and address two issues. First of all, we can rename it anything we want, and for the moment, I'm just going to say it's for heating purposes only. And the reason being is we have to assign it what's referred to as an associated profile. The associated profile is only going to be referenced for design sizing calculations, not the 8760 energy simulation. So I've already got two created here, one for the heating side at 47 or one for the cooling side at 70. But because I've called this the heating one, I'll just make sure it's tagged as such. You don't have to, but you can give it categories if you want for be it heating or cooling. It'll help to have it appear or show up if you're ever looking for it. And hit save. And then I can leave AP Pro and move on to the final step. Lastly, step 6 is to assign the ground heat exchange water temperatures. There are two general types of location for assignment. First, on the heat pump equipment itself as a heat source or a heat sink, and or for heat recovery at the system level loops, assignment can be via pre-cooling or preheating. Both of these assignments are found in the ApacheHVAC app. So if I minimize air side and go to water side, hot water loops, and go straight to the central plant heat pumps that are feeding, in this case, 2 heating hot water loops, more actually. So I'll double click on the central plant heat pumps to open up for the assignment. Back up again. Okay, so I can see I've got 3 different what are set up as water-to-water heat pumps, but the water source and water sink are both set to profile in this instance. So these can be used either as air-to-water heat pumps or water-to-water heat pumps. And because I'm in the heating hot water loop, I can set this to be either a heat pump providing heating and cooling or a heat pump providing heating only. So I'm going to toggle to heating only. Just keep an eye on the water source and water sink, and this will kind of give the clue away of what I was talking about previously. So if the heat pump is doing heating only, then I can set this water source profile to be from Gaia-GLD, freeform data input for the heating. So this will be used both for the energy simulation, and it will have design elements in it set to 47 for the design sizing calculation that will go ahead of it. Now, if those heat pumps were reversible and they can provide heating and cooling, same idea, and this is basically why you would need to set up two of these, one for heating and one for cooling. And because I'm on the heating loop, you don't see the cooling coils, but those are just as easily available to you. So that's it on the heating side. If you want to take a quick look at the cooling, that's the air-to-water heat pumps. I don't want that. I want the groundwater heat pumps serving this instance cooling coil and a chill water loop. So same idea, this time it's cooling or heating or cooling only. And that's why these sort of need to be set up separately. If of course your heat pumps are reversible, if the ground source heat pumps are only for heating only, then fine, you only need to address the heating side of the equation. So that's the component or equipment assignment of the groundwater temperatures. On the system level, there are a few configurations available for the groundwater temperature assignment. For example, in this chill water loop, the groundwater temperature may be used as a pre-cooling heat exchange on the secondary loop return, or even on the primary loop downstream of the bypass. In this heating hot water loop, the groundwater temperature may be used as a preheating heat exchange either on the secondary loop return or even on the primary loop, if there is no independent secondary hot water loop. This preheating uses the heat transfer loop as a source of heat recovery, which is quite unique. So as shown then on the heat recovery loop, which was independent, the loop is only connected with this water source heat exchange from the Gaia-GLD water temperature and with the dedicated heating hot water loop. Finally, additional heat transfer loops may be used as water loop heat pumps in a water to air heat pump system type, which may also reject or acquire heat to other HVAC equipment types shown on this loop. And as a reminder, for any type of system configuration, the ground temperature assignment should only be assigned to the loop whereby the heating loads and or cooling loads were exported from, way back in step 1. That is why it is so important for you to take ownership of the system configuration and exchange of loads data in step 1 through to the temperature assignment in step 6. That concludes the step-by-step demonstration showing the bidirectional data exchange workflow between IESVE Software and Gaia Geothermal's ground loop design software. As a sign-off note, I would like to say that accurate right-sizing of the building's heating and cooling loads are critical to an optimized and right-sized geothermal heat exchanger design, because oversized heating and cooling loads may result in oversized and expensive geothermal systems. This data exchange between IESVE and GLD should help designers to optimize the overall system design.